Good evening, everyone, and thank you for joining today. My name is Apurva, and today me and my colleague Abhishek are going to present the Databricks Lakehouse Accelerator. I will start with the goal of the accelerator. Why is this accelerator needed? So, accelerator was introduced to reduce the time and effort which enterprises need to onboard the Lakehouse environments while keeping their deployments secure, governed, and reusable and scalable. So, traditionally, building the lakehouse environment could take a lot of engineering efforts because the individual teams have to develop everything manually. They had to configure the infrastructure, networking, governance, permission, and workspace components. So, that was handled manually. So, now here the accelerator comes into play. Our accelerator helps to simplify the process. It provides the help of secure deployment of foundations through the SRA, that is the secure reference architecture, automate the governance and compliance setup, and it is also multi-client and multi-environment reusable, and it is workspace aware. So it studies the workspace, what all the resources are present in the workspace. It won't recreate it. It would study what the resources are present, and it would only create the needed resources. And that leads to the support for the analytics, BI, ML, and future AI workloads. Now, before we go into the technical details of the accelerator, we'll start with our agenda today. We will begin by understanding what were some of the limitations of the traditional systems and why many organizations had to struggle with the fragmented architecture and the duplicate data and the complex operations. Then we'll move into the lakehouse approach, where the data engineering, analytics, the business intelligence, and ML workloads are done in the unified platform. After that, we'll see how this lakehouse deployments are done. So the main foundation of it is the security foundation. So in security foundation, we'll see what is the architecture of secure reference architecture, why does it exist, and what are the components, the network security components of it. It will include the private endpoints, DNS, NSGs, and the key vault. Then we will see the main goal of our presentation, that is the lakehouse accelerator architecture, and we will explain here how the accelerator is designed to discover the environments, which applies the governance, support the reusable deployments, and enables the secure onboarding. Then we'll go ahead further and discuss how it handles the governance and the compliance with the help of access control, security, and the deployment governance. We'll also see how this accelerator is a single framework which is used for different environments and different clients. It also supports the integration and the deployment with validation. And once the accelerator is set up, it integrates the data from different resources to get the data which is ready for our reporting purpose, for the business intelligence purpose, and the machine learning purpose. And finally, we will see what all needs to be enhanced in our accelerator, what is the scope of accelerator going further, the future roadmap, and other expansion plans of our current accelerator. So we'll start with some of the inefficiencies in the traditional system. So traditionally, the data in particular enterprise was not coming from one source. There are different sources of the data. It can come from different systems like the ERP system. The transaction data comes from the ERP system. The customers' data would come from the CRM. There would be data coming from the IoT devices, the CSV files, the streaming applications, databases, logs, data warehouses. The data would be there in the BI platform, ML platform, and the pipelines from the ETL tools. So it created various problems when data was coming from different sources in the single enterprise. It created problems like the data silos. So the data was scattered across multiple systems, and there was no single source of the truth. the same data had multiple copies across a different system, and the same data exist in data warehouses, BI system, the notebooks, and the storage account, which led to slow analytics pipeline. So because of that, the data kept moving between different systems, and the ETL and ELT pipelines became very difficult to manage. Also, because the same data was residing in different system, it also led to the expensive infrastructure. Because various tools used to manage the same data, the platforms were different, and it also led to higher compute cost. Then comes the governance complexity. Because there was inconsistent access for different groups and people, the policies were different for different system, and the compliance across system was also different. So one data used to reside in different system, and every system has their own infrastructure, governance, storage, and different copies of the data. And that led to the duplicate transformation. So the same logic was built multiple times in the different system. So these were the key problems because of the data coming from different resources. Now, what problems it created for the organizations were slower time to insights. So because that's um, because because the data was coming from different resources, the time for the insights become difficult, because the enterprise has to take data from different systems, and there was the data preparation took a lot of time, and the analysis become difficult. The second is it also led to the higher operational cost, because there were more tools involved, more people involved, and more time was spent um, maintaining the data. The third was the poor data quality and trust. Because the data was coming from different resources, it was inconsistent, duplicated, and outdated. And it also impacted the business, because the decisions were making slower, and there was less return on investment. So that is when the lakehouse approach comes into the play. So, what is Lakehouse? So, Lakehouse is a modern data architecture that combines the best practices of the data lakes and the data warehouses to store all your data and deliver reliable, high performance analytics and AI. So, traditionally we had data warehouses which are very best for processing the structured data and for reporting, and it also gave the high data quality and the governance. And but it was only used for structured data and reporting purpose. Then came the data lake. So data lake was more flexible, because it has almost all types of data. It could store and manage raw data, semi structured data, and unstructured data. It was also low on cost, and because it could manage all types of data, it was great for um, exploration in artificial intelligence and machine learning as well. But again, due to this flexibility, it was very low on governance aspect and the data quality aspect. So came the concept of lakehouse. So lakehouse uses both the capabilities of data warehouse and data lake. It was created into unified platform for all the data and workloads. So it was one place for all the data. It was high performance with flexibility of the lake, built-in governance, security, and quality. It took the capabilities of the data warehouse to get the quality and the governance, and it took the capability of data lake for having flexibility to ingest and process raw, semi-structured, and unstructured data, and hence it was both optimized for BI, AI, ML, and streaming. Now, what impact it had for enterprises was it gave faster insight. So, as the data was coming from one source of truth, all the teams got a single source of data, and that same data could be used by analysts for reporting purpose and data scientists and ML engineers to build the models. The same data could be used to build and train and deploy models for AI and ML with the governed data. It also reduced the cost because it was a single platform in which data was handled. So uh, all the as the data was fragmented between different system, that problem was gone, and only one platform was there which stored all the data and processed all the data. That it also eliminated the problem of data silos, and it optimized the storage and the compute. And it also became very simple to operate in one platform for all the teams. So initially, the problems with legacy architecture like the data silos, the complexity and the latency, high cost, and limited value turned into a more reliable solution in Lakehouse, which is you will get a data at one place. It would be fast and flexible, trusted and governed with lower cost, as the infrastructure would be less, compute cost will be less, and thus it will unlock more value for the stakeholders. Now we'll go forward and look at the evolution of these data platforms. So how the legacy architectures moved towards the modern lakehouse architecture. So it started with the concept of data warehouses in 1980s to 2000s. Um, so in data warehouses mostly supported the structured data which was used for BI reporting, and that data was used for building dashboards and support the decision making for the stakeholders. But the infrastructure was expensive, and it was not very flexible because it didn't support the unstructured data or the semi-structured data. The examples were the Oracle Teradata and the SQL Server data warehouse. Then came the concept of data lake, which was more flexible. It came across 2000s and 2010. So the concept was of Hadoop was introduced, which was a flexible storage. It also had schema on read architecture, so it could not just read the structured architecture, and it supported both structured as well as the unstructured data, and it also handled the file formats like the Parquet and the ORC. And the governance challenge still remained because it was not as governed as the data warehouse. So the examples of it are the Hadoop, HDFS, and the HDFS ecosystem. So again, the problem was still there of the governance, even though the flexibility was introduced here. Then there was the evolution of the cloud two tier architecture, which was in 2015 to 2019. At that time, the cloud technology came into place, and it became popular, and the cloud storage became standard like the ADLS, S3, GCS, Snowflake, and Redshift. But still, the warehouses handle the analytics separately, and the problem of data duplications was prevalent in this system as well. And because the data was handled between two systems, there was the problem of data movement between the system, which led to the high operational cost and the latency. Then there was the evolution of the transactional data lakes. So now the delta lakes concept was introduced here, which handles the ACID uh, transactions. So here, Iceberg and Hoodie technologies came into play, and it improved the consistency of the data. Spark SQL was enabled for direct analytics on the data lake, and it reduces thus the dependency on the warehouses, and it also supported better governance, like the Delta Lake, Apache Iceberg, and Apache Hoodie. There was the evolution of the Lakehouse architecture, which was just recent from 2020 to presently. We use that Lakehouse architecture. So it combines the flexibility of all the previous architectures and the governance from the warehouse. and it gave us one platform for the business analytics, machine learning, and AI. And it was the open storage with high performance, built-in security, and the quality controls, and it supported end-to-end life cycle of the data movement. So right from the data ingestion to ETL pipelines to getting the outcome of the data for BI and ML purpose, all was handled by the Lakehouse architecture, and it became quickly very popular. So this was the architecture of the lake house. Now, setting up the lake house environment in enterprise was not easy. Hence, hence the concept of accelerator was introduced, because this accelerator is a framework which is reusable to deploy the resources across various environments and various clients. So from here, we'll go ahead and start with the infrastructure of the accelerator. So accelerator is built upon a security foundation, which is the SRA, that is the secure reference architecture. My colleague Abhishek will take from here and explain the secure reference architecture and its components. Thank you.
Okay, so now let's start with the secure reference architecture. So the core secure reference architecture, or the SRA that we built for Azure Databricks, the primary goal over here of this architecture is to create a secure enterprise-ready Databricks deployment that follows private networking and zero trust principle. So inside Azure, everything is deployed within a dedicated virtual network. We separated the environment into multiple subnets for isolation and security purposes. Yeah. So we have a private subnet specifically for the secure Databricks workspace, a separate subnet for the web authentication handling, private endpoint subnet over here, and a optional and utility subnet where services like Azure Key Vault can reside. So one important thing here is that the Databricks workspaces are deployed with no public IP exposure. So access is controlled internally through private endpoints in private DNS routing. And user typically connect through enterprise approved methods such as Bastion host, jump server, VPN, express route, connectivity. So we also integrated Azure Key Vault for centralized secret and credential management. Overall, the architecture ensures like private communication, reduced surface attack, and secure authentication flow in enterprise grade governance. So why does the SRA exist? So a lot of organizations want to use Databricks for analytics, AI, and data engineering. But secure and compliance become their major concerns when workload are exposed publicly. So the SRA actually addresses this by creating a secure and controlled environment. So a user access from a user's access perspective, access is restricted to trusted corporate paths. No right public internet exposure exists. Authentication happens through control mechanisms. From an infrastructure perspective, the workloads are isolated with private virtual networks. Private endpoints are used instead of public services exposure. Network segmentation helps separate responsibilities across components. From the server side, private DNS, network security groups, key vaults, and centralized secret management all work together to strengthen the environment. So I would say SRA would provide a secure landing zone for enterprise Databricks deployments. So there are various components of the secure reference architecture over here. First of all, we have the network security groups. So these acts as a traffic control layer and define which systems can communicate and with each other. And the next is the private endpoints. So instead of sending the traffic over the public internet, Azure services communicate internally through Microsoft private backbone network, private DNS, then resolves the Databricks URL into private internal IPs addresses automatically, ensuring that internal routing remains secure and seamless. And finally, the Azure Key Vault that securely stores the secrets, tokens, certifications. The certificates and sensitive credentials. Okay, from here, Apurva will be taking on the Lakehouse Accelerator architecture.
Yeah, so now we'll come to the core of the presentation, that is the Lakehouse Accelerator architecture. So the Lakehouse Accelerator is built into the 5 layers. It is the layered workspace aware accelerator for secured and governed data platforms. So the first is the foundation layer. So this is the security foundation. This layer would provide the secure infrastructure inherited from the SRA, from the SRA architecture. So it would include the private networking, key vault integration, secure workspace, enterprise access and identities, policy and compliance. All the security related uh, resources is inherited from SRA into the accelerator. Uh, Basically, let's say there is client A, which is a healthcare company, and they don't require public IP address. So our SRA could be deployed in one click, and they would have their private network, key vault integration, and secure workspaces with all the policies and compliances set up. Now, upon this foundation is laid the layer of the Lakehouse Accelerator. So the second layer, here comes the discovery, which connects and discovers the existing resources. So this is one of the intelligent layer of the accelerator. So with the secure reference architecture, the accelerator would connect to the Databricks environment, and it would go inside the environment to see the state of the environment, like what all resources are already present in the environment. When I say resources, it means the objects present in the Databricks workspace, like the catalog, schemas, groups, volumes, external locations, and the policies. The accelerator would discover what all resources are present, and then it would save it in the state Terraform state. Then comes the decision logic. The accelerator becomes smart enough to understand what decision it should make before deploying the resources. So it would ask itself a questions like, what resources already exist, should it be reused, should the Terraform manage it, because the SRA is not necessarily provisioned through the Terraform. It could be managed manually by some of the clients. And should the resources be deployed, or should it skip the deployment process? So this is the layer in which it makes smart decision, and it avoids the duplication of the resources and the conflict. If the resources are already present, which has to be used, it will reuse the existing assets whenever it is appropriate. It is also workspace aware and brownfield safe, meaning that if the resources exist, it will use the resources without showing any error, or won't try to recreate it, creating the conflicting situation of deduplication. And it is also idempotent and efficient for deployments, because even if we run the same accelerator again within the same environment, it won't throw any error, because it is designed in such a way. Then comes, after all this is set up, then comes the governance automation layer. So the accelerator will automate the governance. It will automate the unity catalog structures. It will assign the RBAC assignments, grant the permissions, policies and rules, and the external location based on how it is provisioned. So so for one client, there might be certain grants and permissions given to certain group of the people. The same framework would be used for another client, but if they want the different permission and maybe different schemas under the Unity catalog, that could be changed with some of the configurations, and with the same framework it would be deployed. So because of that, you have to create or manage it creates or manages the Unity catalog structures very well, and automates the RBAC grants and the permissions. It also applies the policies and data governance rules inside the workspace, and manage the external locations and the integrations from different data sources. And then comes the final layer. of the accelerator, that is the data and the workload. So once the resources are created, governance and security is managed, um, comes the main part, that is the data flow. So it follows the medallion architecture, in which you will have the bronze, silver, and gold layers. You The raw data is ingested inside the bronze schema, and more processed data in the data is transformed in the silver layer, and you get a more curated data in the gold layer, which could then be used for the BI purpose or the ML purpose. uh, yeah, so this is the Lakehouse Accelerator architecture. So basically foundation is just like apartment without any furnitures, and once you have the accelerator deployed, it will just discover what all is remaining inside it, and it would deploy the resources whatever are necessary, and it is reusable across different environments and different clients. So next comes the governance and the compliance. So now that we understood what Lakehouse Accelerator, how it is structured, we will see the governance and compliance. So the governance and compliance of the accelerator is based on four pillars. That is the identity and access management, the data governance, security and compliance, and the deployment of the governance. So the identity and access management controls who can access what, and the accelerator will automate the RBAC and permission management for a user group. So instead of manually assigning any access for every client, governance becomes reusable. It also follows the least privilege access, so that the least privileges are given to the groups and to the clients. Then comes the data governance. So it just follows the Unity catalog governance and schema and volume. So once we deploy the accelerator, it would create the schemas under the Unity catalog. External locations and policies would be handled by the accelerator itself. And for the security and compliance part, as it integrates with the existing secure reference architecture, security is already in place. It also gives the private networking support and integration of Key Vault. So it does not Databricks does not need to have their own secrets. It can grab the secrets from already led SRA, and it also has the enterprise ready security controls. uh, the last pillar is the deployment governance. So while deploying the resources, the accelerator is makes use of its workspace aware logic and brownfield safe execution. So basically, when the accelerator runs, it first checks what all the resources are created, and it avoids the deduplication. So the state for the SRA and the accelerator is maintained, and it won't create any destructive changes in the existing environment. And thus the repeatable and reusable deployments is possible. um, yeah. So next is the multi-client and multi-cloud support. So this accelerator framework could be used by multiple clients in multiple environments and for different clouds. So by multi-client support, I mean, if let's say client A have a dedicated configuration uh, for uh, for SRA, and they have their particular Terraform state and independent governance, and accelerator deploys on top of that SRA. Uh, there won't be an issue if client B has to reuse the same accelerator with a different configuration. We just need to get some of the some like the resource group and some of the details from different clients, and just insert it inside our accelerator, and with just one click those resources are deployed inside the workspace. Now the life cycle for the environment is it could be done in different environments like development, test, and prod environments. And for now, we just have the Azure Cloud SRA in place. And with the common governance layer and the accelerator layer, the same can be done for the GCP and AWS SRS, so that they have a shared governance layer and modules and components are reusable, and there is cloud abstraction and portability, and it is designed for future extensibility in the GCP and AWS with the same framework. Uh, Now, CI/CD and deployment automation would be explained by my colleague Abhishek.
So one of the major goals of the accelerator was automation. We wanted the deployment to move from the manual infrastructure provisioning towards repeatable infrastructure as a code-driven deployments. So the process actually starts with Terraform-based source configuration stored in version controls. From there, the pipeline executes multiple stages: validation, security scanning, Terraform planning, approvals, and finally the automated deployment. So we integrated this into Azure DevOps pipeline, so deployment can be consistently reproduced across environments. After deployment, governance components like Unity Catalog, RBAC configurations can also be applied automatically. Uh, Important advantage of this approach is repeatability. Instead of manually configuring infrastructure every time, environment can be deployed consistently in minutes. So this actually improved repeatability, traceability, governance, and operational efficiency. Uh, So once the secure platform foundation exists, the next focus becomes enabling analytics and machine learning workloads. The Lakehouse Accelerator is designed to support a full life cycle from governed data all the way to AI-ready data sets. On the BI side, curated gold data sets, reporting ready tables, and dashboard consumption became easier. For analytics, reusable semantic models, standardized transformations, scalable data structures help create a consistency across teams. For machine learning, featured engineering, ML datasets preparation, experimentation readiness, and reproducibility are supported. And as organizations move towards Gen AI and AI initiative, the platform can support trusted enterprise datasets prepared for AI consumption. So the idea was, we are not just deploying the infrastructure, we are building a secure data platform foundation ready for AI, ML, and for all these future cases. So about the future expansion, finally, the first area is further deployment automation through Databricks asset bundles, notebook deployment automation, or workflow orchestration. The second area is broader data platform evolution, reusable bronze, silver, and gold templates, DLT pipelines, and self-service onboarding capabilities. On the AI and ML side, ML flow integration, model registry support, and future AI readiness became important next steps for us. Eventually, this architecture can expand towards multi-cloud support across Azure. We presently have it on Azure, towards GCP and AWS as well. So the long-term vision is to create a scalable enterprise accelerator that combines security, automation, governance, analytics, AI readiness into a one reusable framework. Thank you. So we have a short video of the Lakehouse Accelerator and the secure reference architecture pipelines being triggered from the Azure DevOps. I'll quickly go over that video. So these were the secure reference architecture pipelines triggered from the Azure DevOps. Sorry. So within a span of 10 minutes, the secure reference architecture was deployed.
Do we have the prior thing when the infrastructure was not in place?
Yes, I think this is the one when we refresh it. So this is the private endpoint workspace. This has all the network security groups, the DNS, Azure Key Vault. So this was the pipeline for the Lakehouse Accelerator. It's deployed within like 5 minutes. Okay, explain all this. It's created all the bronze, gold, silver schema. I think this was all.
So basically, when we opened the Azure, the infrastructure was not in place, and once we run our SRA, all the security foundations got into the place when we trigger that pipeline. And on top of that, the accelerator layer is built in which we trigger one more pipeline, and inside the Databricks, all the resources like inside the Databricks workspace, the resources like the catalog schemas are created. So yeah, once we trigger this accelerator pipeline, it would run and create the resources inside the Databricks. So all these schemas of bronze, gold, silver of the medallion architecture are deployed in the place. And then we go to the permissions for the governance and identity purpose. All the groups have been given the permissions for the catalog, and these are the permissions given on the schema level. So the same permissions are given in the gold schema as well as the silver schema. This is the demo volume in which we list some of the CSVs, and there are three notebooks created policy of no photon, yeah, single node and no photon. So once this cluster policy is enabled, all the metrics below it, like the performance metrics, are disabled, so anyone cannot go and um, edit it. So it helps to reduce the cost of running the cluster for any of the business. And once we enable it for the clients, they are ought to use this. And yeah, this is how they will save their money as well. So the price for the cluster here would be half dbu per hour. And this is the policy that we build for every client, that could be different with little configurations in our accelerator that could be changed and enabled for the clients. So yeah, this is it.
Thank you.
Yeah, any questions are welcome.
Lots of questions. I don't want to hog it, but well, the first thing is what the configure is deploying a lot of where to start. Why would you run it more than once?
The accelerator?
Yeah.
Yeah, because we have like two architectures right now. One is the secure reference architecture, which is for the security. So for any of the cloud security, maybe Azure, GCP, we have that. And the next layer is the accelerator layer. So once we combine it, it would be triggered only once. But right now they are separate.
You're talking about continuous deployment, meaning what are is it this is a one-time setup, or this is something that is continually?
So right now, like if you want to deploy the Lakehouse Accelerator in private endpoints, uh, clients would have their own corporate VNs, but we are using a virtual machine jump box. So we go inside with the help of a gateway like Azure Bastion. We go inside, we set up the environment. We would install like Terraform and other tools that would come into play, and then run the the Lakehouse Accelerator pipeline on the Databricks workspace that is deployed to the private endpoints.
But you don't need to run after those two things run once.
Mhm.
It's not a redeploy continuously kind of thing. it's just a one-time, there's two parts to it.
Yes.
Yeah, for us, when they were developing this, they're in a situation where they're deploying resources and then wipe it out and go back and deploy it again if there's a bug in the Terraform script or something. So they were deploying again and again and again to the same resource group, and just needed a way to make sure that if it ran twice, it didn't screw up what they had just already deployed.
And how does it handle, I'm kind of new to Databricks, I'm thinking about doing it, and I've been reading about how to handle dev, test, and prod. Whether you do it inside one area or you create separate workspaces for each one. Does it have it set up for that? I mean, I know how to run.
It has different environment setups for that. So it handles separately the dev, the test, and the prod environment.
Yeah, so that way the environment.
Yeah.
And then for configuration, I noticed there was some things that are very specific to a company, like the schemas and the names.
Yeah.
That's all configurable.
Yes. Yeah, that is all configurable. Once we scale it further, it is made in the modules are structured in such a way that it is configurable for different companies across different clients and across different workspaces for the same clients. Any other questions?
One other question. Yeah. It sets up the catalog and the schemas and the groups. It doesn't actually build anything inside those, right? Or it doesn't add people to them. It just sets up the architecture.
It sets up the architecture, and that is again when the client has certain user groups to be assigned, that is configurable
to the RBAC module. When you say groups, you consider group of people given a certain permissions in the schemas and everything. So we have a RBAC module in place that is role-based access control module. So that would take care of that.
And how much setup is it to configure everything? Pretty time consuming. I mean, I know it runs really quickly, but like getting all big files with all the right names and groups and everything, is that tricky?
Yeah, it is somewhat tricky. It took time. Yeah, and maybe we are doing it through the Terraform. So
earlier when we were doing it with the command line interface and everything, that was a bit tricky. But when we developed the pipeline and everything, so there are a couple of things that we will have to enter in the dialog box that appears, and just click on run. So that made the process a lot more simpler. And we wish to, like, in a couple of days, we'll be coming with a UI as well that would be more user friendly.
Where you click and say what you want it to be called.
Yes.
Yeah. And about your question to build something inside it, so we have a module of declarative automation bundles which take care of the workflows and the jobs inside it. So it would ingest the data from the resources, and it would run the pipeline to get the curated data for ML and BI purposes.
That would be if you are migrating from something that already exists.
Yeah, for the data ingestion purpose. So right now it just provisions the resources, sets up the architecture in the place so that governance and securities are handled, and then there are the modules to build something, as you said, inside the Lakehouse.
Yeah, and do you feel like that the security architecture? I've seen some other ones for Azure apps similar. I mean, that's pretty much the gold standard for how you would set up the security around the Databricks.
Mm-hmm.
You're saying people access it through VPN pretty much. That's the only way to get into that Databricks.
So Azure actually provides a virtual machine as well as a gateway Azure Bastion. Those are paid services. Those will cost you like around $200 per month. You can always use them.
Yeah, but you could VPN. You just VPN into otherwise.
Yes, corporate VPN also.
Thank you.
Yeah, like if you're within your corporate network, you just log into Databricks.
Yeah.
You just log in through a VPN or API or you can lock it down so that you only hand out an URL that takes people directly into the workspace. So you don't have to have users looking into a resource group and seeing other resources. They don't even have to see into your backend cloud. You just give them a link to click and they go right into their workspace. And the volumes, Databricks has this volume concept that's attached to a schema. You can upload files into the volume and then say like a bunch of CSVs. And you can start doing analysis on sample data right away. And then it's all governed in your catalog because you have a lineage of, hey, it was from this CSV that was uploaded that made this table. So you don't have to let users have access to a storage account.
I have a general question. It's not specifically about this, but I'm asking all the questions that I hope. So we're evaluating Databricks as something we might go to. I just wondered, you obviously the company works with Databricks, so I'm guessing the answer, but you enjoy work. I mean, is it a loaded question like that? Yeah.
It's a Cadillac. Like, especially if you have the interest of data science hanging around, amazing experience.
Yeah.
Yeah. Okay. Plus, if your developers are like, I'm only going to use PyCharm or I only want to use Visual Studio, all of those can connect to Databricks and they can interoperate through their ID.
Yeah. Gardner, Forrester, they all recognize Databricks as top upper right quadrant. Yeah, best of breed.
Yeah, I see that. I just have had, I've never had a great experience with cloud tool. We use on-prem stuff now. Like, you just have a little more control and code-based.
What are you on right now?
We use SQL Server and then Python for most everything we do on-prem. But it works really good and fast. And, I'm a little hesitant to go to a cloud thing just for bugginess, but I probably need to get over it.
Are there any challenges with the current infrastructure?
Yeah, there's some challenges. Nothing that's a deal breaker, but monitoring is a little bit painful when things fail and just stuff like that. Yeah.
How do you guys do model management with your data science projects?
That's a space
to the space.
Yeah.
That's why I'm calling Databricks a Cadillac, because
your data scientists will love Databricks.
Yeah, they're ready to go.
And then you also get this other benefit. All of your models, your serving endpoints are governable in what's called Unity Catalog. That is controlled through SQL commands.
I played around with it. We have a demo instance up right now. Databricks has been helping us with POC. But I'm pretty sold, but I'm just a little nervous.
Well, this is definitely a place you can come if you're like, hey, I'm trying to figure out how to do my usual thing.
Yeah.
How does it flow in Databricks? We've got lots of options.
I'm guessing this kind of thing is an offering of your company, right? Like
the accelerator, it's a
source thing you're putting out there as a.
It's a tool that Perla and Abhishek just got.
Yeah, and again, like why Databricks is again, you get one platform for doing all your operations, like the analytics or ML. You don't have to go into the VS Code for Python IDE to build the ML models. You get the data source directly, and you can work through around for reporting, analytics, or developing ML AI models.
Yeah. I'll say it for offline. I have some questions for you guys as a company, maybe. What we have to talk about here? Maybe it's
Whiteboard.
I am, yeah.
I found you on LinkedIn. I sent you that actual invite.
Yeah, okay. Good.
Yeah. Tell you more about Databricks.
Yeah, I could just, that's where I suppose. Where I work at Marquette University, we don't have funds flowing out the years to pay for consultants, but as we get started, I could see Databricks has been pretty good, but I'm not 100% satisfied with their not their support's bad, but just this hands-on support. To have a resource to ask questions of how would you set this up if you were fully supporting this kind of thing?
Honestly, we can probably just answer a couple of those questions for free for you.
Yeah. be great.
We're nerds that are super excited about it.
Oh, good.
I love looking at other people's data.
Yeah.
Maybe we sign an NDA or something like that.
Yeah, okay. Yeah, I have some, yeah, I have a lot of questions. I haven't formed them all yet in my head, but good. I'm glad I came to the right place.
Oh, yeah.
I have a question.
Yep.
So how opinionated is the medallion layer? Can I add a custom layer to it, or do I have to stick with the gold, bronze, silver?
Or you can add custom data to it. Do you mean like the naming for your schemas, or do you mean the data you want to add inside the?
Maybe I want to add a layer, maybe like a fourth layer. Maybe I have a bronze, silver, and gold. Can I add one more layer?
Platinum layer.
Absolutely. It's just
Yes.
it's a convenient construct. And typically you got three phases. You got raw data, then you got a source of truth. You take that raw data, you clean it up and make it something that everybody agrees on. And then that last typical gold layer is like aggregations and things that make it easy to make reports on. But sometimes I've usually seen it on the left-hand side where it's like a raw layer that then you do a bunch of like schema transformation and data typing to call it bronze. And then you go on like silver and gold after that. But it's up to whatever makes sense for the problem you're solving, for sure.
Yeah, and part is what outputs of the data do you want? What is your goal? How you want to work with that data? It depends on that. So you can add one more schema if you want, but yeah, it depends on the problem you want to solve with the data.
Like conceptually, you can have like bronze, silver, gold as
Yeah.
kind of the three conceptual layers, and then like you can have your raw layer, which is maybe like your, raw data full fidelity, and then you move to kind of silver layer, and now it just kind of split silver into at least two like swim lanes. One is for like staging data where you have all of your common transformations. Maybe you have like 5 or 10 source systems that you're moving into raw, and maybe you apply like the uppercase trim all strings across all of those sources. So you have a kind of a standard set of transformations applied to that layer, and then still within that silver layer after staging, you'll have maybe your first like ERD or your first like data model mapping relationships.
Do you normally, for raw data, this is where I have a little confusion, do they say it's just files, or are there tables on top of those files usually in the raw? Or is that like the same thing in Databricks? It's a file and a table at the same time?
Somewhat.
Yeah.
Right.
Yeah, and those are, we see it in terms of like source systems, like those are two primary categories that we work with.
No, I mean, like if I import, so we, have lots of source systems, we bring in API response basically, and we land it in raw. So it's just the raw API response.
Yeah.
When you land it, I mean, it's a file, right? But don't you have to do some kind of command to make it into a table?
Yeah, totally, to copy the delta.
Yeah. Do you do that usually at the raw
Yeah, that's
level?
Or maybe as you're going into bronze,
Not
like
necessarily.
you could make bronze tables,
Yeah.
delta tables.
So Fred brought that concept of the volume earlier.
Yeah.
So your result payload can just copy that as is to a volume.
Yeah.
And then move that data stays in JSON. We can move that serialized JSON into bronze as a delta table, so it's visible within Databricks.
So two separate things, the raw and then the bronze also.
Yeah, conceptually it will be within the bronze.
Yeah, the volume is the raw and then
Yeah.
And this construct they call catalog endpoints.
Yeah.
Once you put your data into these delta tables, you can go to a table and you can look at it in the catalog, click on a lineage graph, and you can see end-to-end upstream sources and then the downstream consumers. It's super helpful if you've got a lot of different projects going on and somebody says, I need you to come look at this. You can hit that lineage graph and it answers most of my questions right off of that. Okay, where's it coming from? what are we trying to do with it? Okay, it's old mind for not production.
Do you guys deploy like notebooks and other stuff in with repos? I saw that there's that pretty much how you do it.
Constant.
Yeah, that's how you do it. Yeah.
And Perga talked about these data automation bundles, or the declarative automation exchange a few weeks ago. It's basically a YAML file that to promote to different environments.
Cool. Yeah. You're convincing me. Doesn't matter.
Dude, it's not bad. I mean, if data science is in your wheelhouse, it makes the workflow so much better.
Yeah, that's definitely. We have a cohort of data scientists that want to do more. There's also a big Gen I's, desire to communicate with some of these things that are easy to communicate with now.
And when you understand certain things about how data works, you can run that thing for pennies on the dollar.
Yeah.
Maybe you don't use all the comfortable features like serverless, and you actually spin up dedicated clusters.
Yeah.
I mean, they run, it's like 25 to 50 cents an hour to run one of these things.
Yeah. Yeah, that's what I like about it. Because we, obviously we don't have a huge staff. We're not going to be using 20 hours a day kind of world. They had mentioned Databricks, specifically their salespeople, about, you can commit in Azure for a certain amount, or you just pay as you go. Is that the common paradigm, like pre-commitment, or is that them doing the sales?
You can use it effectively. It's similar to the supply chain problem of choosing your parcel carrier.
Yeah.
They've got all these schemes about, well, if you ship parcels in this tier, then you get this discount.
Yeah.
And so basically, if you look at your consumption, you can sign a contract with Databricks. Say, I'm going to use it in Azure, and we know we're going to burn this much juice. And then Databricks says, oh, well, if you commit to burning that much juice, then we're going to cut your rates in half, something like that.
You signed that contract with Databricks, not with Microsoft?
Correct.
So it could be either.
True.
So Azure Databricks would be through Microsoft.
Oh, would be through Microsoft, yeah.
But the serverless route would be Databricks, right?
Okay, I thought that, I'm not sure, but I thought the commit contracts were direct to Databricks all the time.
I don't know. They confused me about who we actually end up paying, but he said it all just comes out of your Azure bill. Because you commit, it comes to your monthly.
That is true. It shows up all in your Azure bill. It's consolidated billing.
So the paper, like you sign a contract with Databricks, but for so Azure Databricks is the first party service.
Yeah.
So you'll see Azure Databricks within your Microsoft Azure bill.
Yeah.
Okay. So yeah, paper-wise, you'll have to pay for it.
And then Azure Databricks is a first-party service.
Yeah.
So like if you call the help, if you ask for help, it goes to Microsoft first. And if they can't figure it out, they'll call it Databricks. But it means that in Azure Databricks interoperates with all the other tools.
Yeah. Can you share that slide? Because I would like that reference architecture, because I want our security people are actually doing a review right now.
Okay, you want the architecture of your security foundation?
Well, your first couple slides where you go into the security part of it would be really helpful.
Yeah, so actually a few have pinged me on the slide deck, so maybe we'll just post it to everybody that's on the website.
Let me put it this way, this is a good start, but it doesn't give you enough information to go do it yourself.
Yeah.
But it's a start to see at a high level how it's laid out.
Yeah. Yeah, we're architecting another solution in Azure. We just haven't ever done that on Marquette yet, having a cloud hosted custom, but like where we have to do all this, back end setup with the VNets and have that yet. So I think our systems people, who are cloud people, also are kind of struggling with the concept of things.
It's not the same thing as setting up an on-premise data center. it has a little look and feel like it, and honestly, people who have been configuring hardware in an on-premise setting, they can figure out all the CIDR blocks and the connectivity in the cloud faster than most people.
Yeah.
But it's just it is a totally different mindset. And that private DNS at the bottom there, super, and this is in the secure reference architecture, super important, especially if you're gonna project your on-premise information up into the cloud.
Yeah.
You need to make sure your DNS is linked. You need to have DNS working on-prem. Otherwise, it's a disaster. I still have scars from some of those problems.
Yeah, that's a good call.
Because then all of a sudden you're trying to spin up machines and it's like, we can't connect.
The network interface part of it, that's just through the private endpoints. That's not a separate thing.
It's a separate device, but it lives in the cloud.
Thank you. Very helpful.
Thank you.